Hey everyone, it's me, Miss B. And in today's video, we're looking at the Unit 2, Lesson 13 practice problems for Illustrative Math Algebra 1. So this unit was, well, not this unit, this lesson is all about solving linear equations with systems of linear equations using substitution. So when we talk about substitution, I like to think of the most common way we think of the word substitute, and that's with the substitute teacher. Class is the same, but you just have a different teacher, and it's still in the same room, still got all the same people in there other than your teacher. Still the same subject, all that fun stuff. Everything else is the same except for your teacher. That's the way that this is going to work here. So this first question, we want to identify a solution to this system. I'm going to work through this using substitution. And I'll show you what I mean by like everything stays the same except for one thing. I want to identify a variable to use as the quote unquote teacher, and then represent that with something that it's equal to. So, but I don't have just x or just y equal to something here. But I am going to use this equation here and change it so that I have just x equal to something on the right. And we're going to do that by starting off and adding y to both sides. So when we do that, that will cancel here and we'll have x equals y minus 7. I like to write the variables first. You can write negative 7 plus y. That's fine too. And so I am going to plug this in. We're going to say that x is the teacher, but they're going to be gone for a day. So in their place, who are we going to have sub? We're going to have y minus 7. So if we use that bottom equation to find our teacher and our sub, the top equation is going to be what class looks like that day. So class is going to look almost exactly the same, but instead of the teacher, we're going to have a sub. So I would say here, negative 4, because that's not the teacher, just x is the teacher, in my analogy here at least. So just x is what we're substituting. But teacher's not here, so this now becomes, instead of x, we get y minus 7. And I'll put that part in blue. And I'll do the rest of everything in red. But everything else about the rest of that day, or in this case, the rest of this equation, is the same. So plus 3y equals 23. And from here, we're going to multiply all of this out, and we're just going to find an answer for y. So let's distribute this negative 4, negative 4y, and then 7 times 4 is 28, but it's going to be positive because two negatives make a positive, and plus 3y equals 23. Okay, so we're going to combine like terms. That means for me, negative 4y plus 3y is going to make negative 1y, and then we still just have plus 28. That's going to equal to 23. Let's subtract 28 from both sides, and that will leave us with negative 1y equal to negative 5. So here, if we divide by negative 1, we get that y is equal to 5. Now, I only have one case where y is equal to 5 for my options, but we're going to keep going and I'll show you just where you would go from here generally. When I get y equals 5, I then take this back to the equation because, you know, after you have a substitute, they go and report back to your teacher how class went. So we're reporting back now. So now y is going to be 5. So we're going to say, okay, x is equal to 5 minus 7. So then now x is equal to negative 2. And that is the entire process. And I like to write this as an ordered pair, as you should, with the x value and then the y value. So I would write this as negative 2 comma 5. And that is how they want us to give our solutions here, because that's how they have them over here, which means B is going to be your answer, since that is the one with negative 2 comma 5. So that's substitution in a nutshell. Let's keep it going here and look at number 2. So Lynn is solving this system of equations. And she starts by rearranging the second equation to isolate the variable and creates y equals 4 minus 1.5x, and then substitutes that into the first equation as shown. So we want to check to see if Lynn's solution makes both equations true. So let's do that first. Lynn's solution is negative 36 and positive 58. Let's go up to our, when it says both equations, it means these equations up here. Right there, we want to plug that in. So we're going to do negative 36 and positive 58. So for our check here, we'll have 6 times negative 36 minus 5 times 58. And we want to know, is that going to be 34? And then the other one we're checking is 3 times negative 36 plus 2 times 58. And is that equal to 8? Okay, so checking this first one, these numbers are kind of big, so don't be afraid to use a calculator. I'm using a calculator here myself because I want to make sure I don't do this wrong. But even then, you can still mess up when you use a calculator, so just be careful. So 6 times 36 is going to give us 216, negative 216 actually. And then we're going to subtract even more from that. So negative 216 and then minus 5 times 58. That's 290. That is absolutely not equal to 34. So we really only even need to check one, but we can check for the other one and just see if the second one works. Because you could have checked the second one first, and either way, I'm going to show you what it looks like. So 36 times 3 is going to give us, well, negative 36 times 3 is negative 108. And then 2 times 58 is going to give us 116. Is that going to be equal to 8? Yes. So this one, it would make true, but this one, it does not. So for the top one, we're going to say no is our answer to that, because it has to make both, and it doesn't make both of them true. All right, so for part B, it said, if your answer to the previous question is no, then we want to find and explain her mistake. So since our answer was no, that's what we're going to do. If the answer was yes, then we would graph them to verify the solution. So we're going to find Lynn's mistake. And I think that Lynn's second equation is fine for the 4 minus 1.5x. That's going to be okay. So Lynn's substitution part is fine. We're going to check Lynn's work here. So first thing that Lynn is doing is distributing. And I see it. Okay. So if Lynn is distributing here, we get negative 20, but then I have negative 5 times negative 1.5. This negative sign, that should be a positive. So we're going to say this should be plus 7.5x. Because the numbers are right, but a negative times a negative is going to make a positive, and that's not what Lynn has. So how can we explain her answer? He did not he did not distribute the negative on negative 5 to the negative 1.5x. He got negative 7.5x, and it should be plus 7.5x. There we go. That's it. We were just asked to check her solution and then to actually find where her mistake was, since we did have a mistake. Okay, now that's going to bring us to question 3, which is two different systems of equations to solve here, A and B. So let's just look at A first. A over here is not going to be too hard. I do see that we have a teacher and a sub, but in this case, it's the way we're used to kind of seeing things. We're used to seeing a variable equal to a number, and so all we're doing is the same thing as just quote unquote plugging it in. But I'm still going to practice using my parentheses here. It's always best to plug things in with parentheses in your other equation. So this bottom equation is just telling me who the substitute is. Let's see what the day looks like then. So 2 times 4 in parentheses minus 4y equals 20. So let's multiply this out. This is going to be 8 minus 4y equals 20. And then we're going to get, let's subtract 8 from both sides, because I want to get the y by itself. So minus 4y is equal to 12. Getting closer, we're going to do one more step, divide by negative 4 on both sides to keep things even here. And when we do that, we're going to get that y is equal to negative 3. Now we have no more steps, actually, because they already told us the number for x. Normally, I would take this back up and say, okay, we're going to report back. How did things go? What do we get for the teacher? Well, we already know the teacher was 4. So in this case, we have 4, comma, negative 3. That's our answer. Now with B, this equation here gets a little more complicated. And I see a variable by itself here. I see y. So y, that's the teacher, but who's the sub for the day? Sub for the day is going to be 6x plus 11. So I like to think of the other equation as class, and let's see what class looks like with a substitute teacher. So 2x staying the same, minus 3 staying the same, but the only thing that changes here is y, and y becomes 6x plus 11. There's my sub, and it's still equal to 7 because everything else about that equation stays the same. Now, we get to multiply here. We're going to take this negative 3. You have to remember that the negative comes with it when we distribute. So that was Lynn's mistake in the one above. She didn't bring the negative 3 with her to every single piece. So not negative there, 2x there. And this is going to become 6 times 3, which is 18. So negative 18x minus 33, and that's equal to 7. Let's combine our like terms here. We'll get negative 16x minus 33 equals 7. We'll add 33 to both sides. So that will leave us with negative 16x. And then on the right-hand side, we're going to have 40. And then we do still have one last step, which is to divide both sides by negative 16. Now you're not going to get a whole number here. You can leave it as a fraction. You can write it as a decimal. You're going to get negative 2.5 or negative 2.5, or basically negative 5 over 2. So I'm going to write it as both negative 5 over 2 or negative 2.5. We're probably going to plug in the decimal form because it might be a little easier. But yeah, so once we have that, then we're going to come all the way back up to the top, and Yeah, I guess you can consider like this equation is like what class looks like with the sub, and like this is how it goes. And at the end of the day, substitute teacher reports back to the regular classroom teacher and says, hey, this is how class went. Turns out x is equal to negative 2.5. And then y, since y is my original teacher here, I guess, is going to say, oh, okay, great. So 6 times negative 2.5 plus 11. So if we multiply that part out, negative 2.5, we're going to get here that it's going to be negative 15 plus 11, and that's going to leave us with negative 4 for y. Then we're just going to group them together. So this will be negative 2.5, comma, negative 4. And that is the answer to this one. So hopefully those weren't too painful. Let's move on to the back. For number 4, Tyler and Han are trying to solve this system by substitution. And Tyler's first step is to isolate x in the first equation to get x equals negative 5 minus 3y. Han's first step is to isolate 3y in the first equation to get 3y equals negative 5 minus x. We want to show that both first steps can be used to solve this system and yield the same solution. So we're basically just going to show both steps. So what are they saying? They show both first steps can be used to solve the system, and it's going to have the same equation, but like, yeah, it's going to have the same thing. So let's do Tyler's first step is to isolate x. Let's do Tyler's first step. He's using x equals negative 5 minus 3y. So that means that's the substitute teacher right there, negative 5 minus 3y. So on his equation, when he has 9x, it's now going to become 9 times negative 5 minus 3y, and then plus 3y equals 3. And let's work this one out, and then I'll show Han's first step. So 9 times negative 5, we're going to have negative 45. 9 times 3 is going to be negative 27y plus 3y equals 3. So we will have, let's combine the y's here. So we'll have negative 45, and then we'll have minus, and I believe it's going to be 24, yeah, 24y. That's equal to 3. We'll add 45 to both sides. I'm going to bring my work back over, and we'll show negative 24y equals 48. So when you divide both sides then by negative 24, we're going to get here that y is equal to negative 2. And if y is equal to negative 2, we'll plug it right back in and solve for x. So x, oops, that's an eraser, x is going to equal negative 5 minus 3 times negative 2 instead of y. So then the x value is negative 5 plus 6, so x is 1. So this was Tyler's, I believe. Yeah. So I got those answers in red. Now I'm going to use Han's method and show that way instead. So Han's first step is to isolate 3y in the first equation. And Han is using 3y equals negative 5 minus x. So 3y is teaching class, and substitute here is negative 5 minus x. The second equation, it's 9x plus 3y. So 9x is going to stay the same, but instead of 3y, we're going to have plus negative 5 minus x. And that's going to be equal to 3. Okay, so we're going to keep going here. Now in this case, I don't have anything out front to multiply with those parentheses. So I actually just get to drop them. I can consider it an invisible 1 out here that's being multiplied. but 1 times anything is just itself. So we would have 9x minus 5 minus x equals 3. 9x minus x is going to give us 8x minus 5 equals 3. If we add 5 to both sides, you will get that 8x equals 8. So that means that x is equal to 1. Hey, I'm seeing part of my solution appear again, x equals 1 and x equals 1. I still have to show the last piece, which is to find y. So plugging it back into, in this case, we're plugging it into an equation with 3y, so we are going to divide by 3 at the end here. That's going to be equal to negative 5 minus 1. I still plug these in parentheses because if that number ends up being negative, I do need to remember that I'm going to multiply a negative with another negative. In this case, it's positive, so it doesn't matter that much. So we'll have 3y equals negative 5 minus 1 is negative 6. Divide both sides by 3, and you'll get y is negative 2. And so for both, I'm going to write this in a third color. I can say both give 1 comma negative 2. Put my box around that as an answer. So I showed that they both gave the same equation. That's question number 4. That brings us now to question number 5, which is less about substitution and more about just solving for specific variables, which is very handy in substitution, so it's good to know how to do that. Okay, so Kieran's buying supplies for his school's greenhouse. He buys F bags of fertilizer and P packages of soil. It's $5 for each bag of fertilizer, $2 for each package of soil, and he spends a total of $90. And then they're giving us an equation. The equation 5F plus 2P equals 90 describes this relationship. So if Kieran solves the equation for P, what is the result? So Kieran is solving the equation for P. That means get P by itself. So automatically, if I need to get P by itself, I know it can't be this first option because this is 2P. P is not by itself there. So we can cancel that one out. But let's actually just look at what we have. So let's use 5F plus 2P equals 90. And really, I just want to get P on its own. So I want to take care of everything else that's not highlighted first. That includes the 5F, and it includes the 2. 5F is going to be a little easier. And because we know we need to do things to both sides, when we subtract 5F, we're subtracting it from the left, but we're also going to then be subtracting it from 90. So we'll have 2P equals 90 minus 5F. And it's okay to not have a number for that. We don't need to know what the number is. We just know that when we do get it, we're going to subtract it from 90. So even if we don't know what F is, it's still fine. The last step we're going to take here, in order to get P on its own, is divide everything by 2. And so normally, I would just consider this piece here to be my answer. But when I look over to the left, I don't really see anything like that over here. Is that this? Not quite, because this is 5F minus 90 instead of 90 minus 5F. So it's not this one. The option C doesn't even have anything divided by 2. And option D has 85F divided by 2, but those aren't like terms, so I can't actually combine it into 85. It's actually going to be C, and I'll show you why. They're actually just doing that division. So 90 divided by 2 is 45, and 5 divided by 2 is 2.5, so it's going to be minus 2.5F. So there are multiple ways to show this fully, and C is the correct answer here. Let's actually circle this whole thing because I didn't want to cover over part of it with my answer circle there. And that's number 5. For question 6, they're asking us to find the x and y intercepts of the graph of each equation. I think the easiest way to do that is to plug in 0 for the other numbers. So if I'm trying to find the y-intercept, I'm going to plug in 0 for x. So we would have y equals 10 minus 0, so y is 10. So the y-intercept here is 0, comma 10. And then for the x-intercept, we're going to have 0 equals 10 minus 2x. Add 2x to both sides, and then you'll get that x is 5. So this means 5, comma 0. And that would be the x-intercept, and the one on the left here is going to be the y-intercept. So plugging in zeros, easiest way to find your intercepts. Let's do the same thing for b, which is right below it. So plugging in, I like to find the y-intercept first. Plugging in 0 for x means you have for y plus 0 equals 18. So really just 4y equals 18. And we're going to not get an even number or a whole number here. It's going to be a fraction or decimal, and that's okay. So divide everything here by 4, and you'll get that y is 18 divided by 4, which is also just 4.5. So we can say 4.5 or 4 1/2. I'm going to use 4.5, and that means that the y-intercept is 0, comma 4.5. Now for the x-intercept, we're going to plug in 0 for y, and so we would just have 9x equals 18. When we divide both sides by 9, we're going to get that x is equal to 2, and so we would have 2, comma 0. So x-intercepts and y-intercepts. Okay, let's keep moving. We're gonna use this top equation first. 6x minus 2y equals 44. Let's plug in 0. Let's plug in 0 for y first, and we'll just go with 6x equals 44. Now it's not going to divide evenly, and that's okay. But when you divide both sides by 6, 44 is going to give you 7 1/3. So your x-intercept here, let me actually move this, my handwriting's a little too big for this space. So your x-intercept would be 7 1/3 or 7.3, but that would repeat, and we'd put a bar over top of it. 7 1/3, comma 0 for the x-intercept. Then if we do our y-intercept, we end up with negative 2y equals 44. Just because we're plugging 0 in here doesn't mean that this negative all of a sudden doesn't exist. It just means that the 6x doesn't exist. Okay, if we divide both sides by negative 2, you'll get that y is equal to negative 22. So you would have 0, comma negative 22. And these would be your two intercepts. Last one, not quite standard form, not quite slope intercept, still works just fine. Let's plug in 0 for y first, and we'll do 2x equals 4. If you divide both sides by 2, x is equal to 2, so you have 2, comma 0. And then the other way around, you would have 0 equals 4 plus 12y, so negative 4 is equal to 12y. Divide everything here by 12. 4 divided by 12 is going to give you 1/3, but it's going to be negative, so y is going to be negative 1/3. So we would have 0, comma negative 1/3. And that's how we would find all of these intercepts. So hopefully me showing my work here helped you out a little bit. I might have done it a little bit shorthand or skipped over writing out some steps fully. That's just because I was running out of space, but hopefully, if you have any questions, make sure you ask in class to clarify those. So let's move to the back where we can do questions 7 and 8. And back at the third page. We already were on the back of the page here. We're gonna move to the next page and do 7 and 8, and then we'll be done after 7 and 8, so that'll be great. Okay, so for question 7, Elena wanted to find the slope and y-intercept of the graph of 25x minus 20y equals 100, and she decided to put it in slope-intercept form first. She concluded that the slope is -5/4 and the y-intercept is 0, 5. What was Elena's mistake? Okay, so they're telling us she made a mistake. Let's read through this. It looks to me like they're saying, let's subtract 25x. And then that cancels, and that's good. But this negative sign in front of the 20y disappeared. And it should not. So, Elena's mistake was she forgot the negative on -20y when she brought it down to the next line. Okay, so she forgot her negative. All right, so what are the slope and y-intercept of the line, and explain or show your reasoning? So let's actually do that part, because she was right. We can subtract 25x from both sides, but we would have -20y equals 100 minus 25x. And now we're going to divide everything here by -20. So that's going to leave us with y on the left side. And 100 divided by -20 is going to make -5. And then -25 divided by -20 is going to be positive 5/4 x. And now normally this bothers me a little bit, so I'm just going to rewrite this as y equals, and then I'm going to put the m and x portion first. So 5/4x minus 5. So we can say slope is 5/4, and the y-intercept is -5, but I'll just write 0, -5. That is much better because it's accurate. Okay, so we found her mistake and fixed it. Question number 8 is about two equations and using some graphing technology. Well, I'm not going to use technology to graph these, but you can use technology to find some of these points. So I'm going to first start out, I'm going to say that equation number 1, that one's going to be red, and then equation 2 is going to be blue. I'm going to start by graphing these. You're welcome to use graphing technology. You can use desmos.com /calculator, and that'll give you the graphing calculator. But equation 1 here, this is in slope-intercept form. It's a little bit off the screen, though, for +8. It's going to be off the screen here. It's going to be about here for 8 where it intercepts. And then its slope is up 3/1 because it's got a slope of 3/1. But I can't go up and to the right. I'm going to have to bring it down and to the left. So it's going to come down 1, 2, 3, and then over 1 to right here. And I'm going to repeat that pattern as I go. Okay, so now this, nope, it's not going to snap to a straight line. Love that. Okay. Apparently it was just detecting me drawing a whole bunch of lines there, all at once. So here we go. That looks pretty good right there, or close enough. And now we're gonna graph our other equation. So we could actually graph this other one based on intercepts because that's how I know how to graph standard form stuff. Or you can put it into slope-intercept form. I like to use the intercepts though, so let's practice with that. If I made this part go away, I would have 2x equals -6. So my x-intercept would be -3 when I divide everything by 2, so -3 comma 0. And then if I plugged in 0 for 2x, I would have -y equals -6. So that means positive y is +6. So I'm going to use both of those as my intercepts and just graph between them. So 0 comma 6, that's going to be right here. And then -3 comma 0, that's going to be right here. I'm going to draw a straight line between them. Ah, I see a point where they cross. Okay. So let's actually get this a little more straight here. Here we go, just like that. This point right here is where they're going to cross. My red line is a little bit off, so let's actually fix that up a bit. Red line is a little off. Let's redraw you, especially because now I know where the actual points are for the red line. It'll be a bit easier to actually draw this accurately. So we're going to use that point right there. This is going to be the intersection or their answer. That's going to be something that's a solution to both. And so this lands at -2 on the x and +2 on the y. So it is -2 comma 2. And that's what I'm going to put down here. So -2 comma 2. I jumped ahead because apparently part C says graph the two equations. But we want to find a point that's a solution to equation 1, but not equation 2. Well, equation 1, that was my red line. So let's actually draw this one out a little bit longer. I can use any of my other points here. So let's use this one here. That's -4, -4. So that's going to be a solution to equation 1, but not number 2. And for the blue line, we can use either of those intercepts that we found because neither of those actually touch the the red line. A point in between touches them, but the intercepts themselves don't. So let's use 0 comma 6. The other thing you can do is you can just pick a value for x and plug it in and see what resulting value of y you get. So, but that's how I would do that one, especially if I had graphing technology. You can use a table or something or a calculator to help you plug numbers in. But this is how I would do this equation. And yeah, the point where they cross is going to be -2 comma 2. So that's it for this homework assignment. Thank you for sticking with me. I know it can be kind of a lot when we're talking about substitution and all this graphing stuff, but hopefully my explanations helped clarify a little bit. So again, this has been the Unit 2 Lesson 13 practice problems for Illustrative Math Algebra 1.